Hello everyone. Today we're going to continue solving our quadratic equations. They are always going to be in the form of ax squared plus bx plus c equals 0. We already learned how to solve by factoring, and we've also learned how to solve by using square roots if there are perfect squares involved. So sometimes when you do all that, there are no perfect squares and there are no factors that add up to b. They're like 1.5 or 1.279. So no one's going to be able to compute that. So what we have to use is our quadratic formula. So the quadratic formula is this part right here that I'm boxing off. This is known as the quadratic formula. Quadratic equation is the ax squared plus bx plus c equals 0. So for our quadratic formula, we are finding our values of x, okay? So our values of x normally would be our factors of c that add up to b, and then you subtract them to the other side or add them, and you have your answer. Well, here we aren't actually able to factor them. So we have to use the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, the important thing is that you know it's all over 2a. The other thing, notice we are not using the x squared term and we are not using x. We are using the numbers that are in front of the x squared, in front of the x, and then by itself. So we're going to do some examples here. I'm going to work them out, and you can obviously speed up or go as slow as you want through this part of your notes. So for this one, we have d squared plus d minus 30. Okay? So in this case, we have a 1 in front of our d squared, and we have a 1 in front of our d. Again, this is the same as saying ax squared plus bx plus c. So when we are plugging in these values into our equation, I'm going to go ahead and do this. Oops, didn't mean to do that. I'm going to paste that there and paste that here as well. So what I'm going to do is I'm going to take out my b value here, and my b value here. I know that my b is 1 because that is what it says right here. So here we go. Now I'm going to remove my a value, the a, and I am going to plug in 1 for a as well. And the last thing I'm going to do is replace my c with my c value, which in this case, my c value is negative 30. Okay, so now I'm going to compute my values. My values are going to stay the same the entire time. So this is negative 1 plus minus. We follow our order of operations. So 1 squared is 1. And then 4 times 1 is 4 times negative 30 is actually going to give us negative 120. All divided by 2 times 1, which is 2. All right. Now, if you remember back to basic algebra, whenever we see a negative negative, it becomes plus a positive. So when we solve this part, our x equals negative 1 plus and minus the square root of 121 all over 2. When we actually solve this and get an answer, we are going to solve 2 problems, because remember, our x squared term means there are 2 solutions to this problem. They may be the same solutions, but there are 2 solutions. So when we solve this, I'm going to have x equals negative 1 minus the square root of 121, all divided by 2. And I'm also going to have negative 1 plus the square root of 121, all divided by 2. Now, when we do the square root of 121, that is 11. So I have negative 1 minus 11 all divided by 2. Negative 1 minus 11 is negative 12 divided by 2 gives me negative 6 for one of my x values. The other one will be negative 1 plus 11 all over 2, which this will give me 10 divided by 2 gives me 5. So my 2 values are negative 6 and positive 5. So in this case, I would have been able to factor this, but I am showing you that you can use the quadratic formula when you don't know, is it going to factor out? Is it going to work? Should I use squares? Should I use square root? Should I use the quadratic formula? You can always use the quadratic formula, but so that you know, on the test you will need to be able to do square roots, factoring, and the quadratic formula in order to solve your problems. All right, so here is our next one. I'm going to, again, paste that equation right here. So remember that starting with our green, this is our green value here, or our B, negative 59. So I'm going to erase these. And I'm going to put negative 59. Sorry, that squished in there. My next thing that I'm going to do is I'm going to erase my A's, and I'm going to put in my A value of 30. And then the last thing that I'm going to do is I'm going to erase my C, and I'm going to put in my C value, which in this case is 28. All right, definitely getting the calculator out because I have no clue how all these numbers multiplied without using a calculator. Okay, so first thing, I know that negative 59 is the same as saying positive 59, plus or minus. Now, remember when you do negative 59 squared, if you do 59 negative squared, you're going to get a positive value. Good, that's what we need. You can also do negative 59, close your parenthesis, and then square it, and you'll still get the same answer. So here we have 3,481 minus, now I'm going to do 4 times 30 times 28. And this gives me 13,440. Okay, I thought I did something wrong there. I'm going to try it one more time. 4 times 30 times 28. Okay, sorry about that, guys. Okay, so you should get 3,360. All divided by 2 times 30. I can do that in my head. 60. All right, so following my order of operations, I'm going to take 3,481 and subtract 3,360, and I get a positive 121. So now I have 59 plus or minus the square root of 121 all over 60. Well, I know the square root of 121 is 11, so that means I have 59 plus 11 all divided by 60, and I need to figure out 59 minus 11 all over 60. We got 59 plus 11, 70, and I divide by 60, so that gives me approximately, if I'm looking at it, we had 70 over 60. If I reduce that, that gives me 7/6. So I'm going to leave it as a fraction, not a decimal. Again, please leave it as a fraction, not a decimal. Now, 59 minus 11 should give us 48. 48 divided by 60. Both of these are divisible by 12. So this will give us 4 over 5. So our x values in this case for our solution are going to be 7/6 and 4/5. Those are our two solutions. Now again, even though we were able to get the square root of 121, we still didn't get a whole number value as our solution. So this is why we would have to have used the quadratic formula in this case, because we could not have figured out factors of 28 and 30 that would add up to negative 59 and figure it out. All right. Somehow this one, our 0 got deleted. So now we have w squared plus 6w minus 48. Okay, so I'm going to use our pretty diagram here. Remember that this is our b value. This will be our a value, which in this case is 1. And our c value is going to be negative 48. All right, so I'm going to plug all that in. So I have x equals negative 6 plus or minus 6 squared minus 4 times 1 times negative 48, all divided by 2 times 1. Okay, so now I'm going to figure this out. X equals negative 6 plus or minus the square root of 36, because I know 6 squared. And then I'm going to do 4 times 48, and remember that our 48 is negative, so I get negative 192. Now it doesn't matter because these are going to end up adding together. That 92 is bigger than 36. We remember our rules. This becomes a giant plus. So 36 plus 192, we have 228. So now I have negative 6 plus or minus 228 all divided by 2. So now I'm going to see, is 228 a perfect square? I don't think it is, but I'm going to check. Okay, it's not. So it comes out as an improper long decimal. So what that means is that this is not a perfect square. But if we remember back to simplifying radicals, this probably would have been in February, end of January, beginning of February. When we look at this, the square root of 28, we know, because this is an even number, it's divisible by 2. So 228 divided by 2 gives me 114. Well, this is a prime number. Now I'm going to look at 114. I know that that's divisible by 2 as well, and that gives me 57. Now 57 is prime. So whenever we're taking the square root of something, if we're taking the square root of 2 to the second, that's the same as saying the square root of 4, which we know the square root of 2, square root of 4 is 2. Now the square root of 57, not possible. It's a prime number, so it would just be simplified to 2 square root of 57. So when I have my answer over here, I'm going to have negative 6 plus or minus 2 square root of 57, all divided by 2. Notice, I'm not using any decimals. Do not convert these to decimals. Okay? Now, if I look at each of my terms, this term, 6, 2, and 2, all those are divisible by what value? At this point, you should have said 2. So if we divide both the top and bottom by 2, this would become negative 3 plus and minus 1 square root of 57 all over 1. In other words, just this, and this is our solution. Okay. Again, we are not converting it into decimal form. Do not figure out what negative 3 plus 1 square root of 57 is as a decimal. If you do that, you won't get your full points on your test. So make sure that you leave that in radical form. All right. Now, we're going to continue using our quadratic formula, which we've been using this whole time. And that is the negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So on this one, go ahead and fill in the blank. This is my A, this is my B, and this is my C. So I have x equals 6. And the reason I'm writing positive 6 is because in our quadratic formula it says negative b. Well, b is already negative. A double negative is a positive. Okay. Now, plus or minus. I'm putting this in parentheses so that I remember that's really negative 6 times negative 6, not 6 times 6 times negative 1. Then minus 4 times my A, which is 1, and negative 3, which is my C value, all over 2 times my A value of 1. I'm going to simplify it down. 6 plus or minus the square root, 36, minus negative 12. Remember that when we have a double negative, it becomes plus a positive. So this is all over 2. Now we have x equals 6 plus or minus the square root of 48 all over 2. Now, the square root of 48, I know, is not a perfect square. I'm just showing you in the calculator that it is not a perfect square. It does not come out as a whole number. So we're going to have to simplify using simplifying radical rules. So we know that 2 can go into this. So 2 is prime. 48 divided by 2 is 24. 2 can go into into 24, and that leaves us with 12. Then we can simplify by 2 again, and this becomes a 2. And this is 2 and 3. Okay, so our prime factorization here ends up being 2, and then we have 1, 2, 3, 4 to the 4th times 3 to the 1st. Remember that back when we were simplifying radicals, whenever we're taking the square root of something, that's the same as saying I am taking half of my exponent. So this would be 2 to the second, because 4 divided by 2, or 4. Now, if I didn't know that, I could do 2 to the 4th, which 2 times 2 times 2 times 2 is 16. If I take the square root of that, that gives me 4. Now, 1 over 2, that's a half. So that means that my square root of 3 is going to remain there. Okay. Now, when I go back, my answer is going to be 6 plus or minus 4 square root of 3 all over 2. Well, this is going to be a little simpler because I now know that 2 can go into both 6, 4, and 2. It does not matter what's underneath the radical, whether that can go in there or not, because 4 times the square root of 3 is its own term. So now I'm going to divide everything by 2. So my answer ends up being 3 plus or minus 2 square root of 3. And this is my solution. Okay. Again, factoring this would not be possible without the quadratic formula. All right, we're going to go on to our next example here. Remember that we have our quadratic formula here. Our problem is that this part, the 2x squared minus 4x equals 1, is not equal to 0. So we simply subtract our 1 to the other side. Remember, we have to use like terms. So this simply becomes 2x squared minus 4x minus 1 equals 0. Now I can plug in my information. This is my A, this is my B, this is my C. So I am going to have x equals positive 4, because right now it's negative 4, and the opposite of negative 4 is 4. Plus or minus the square root of negative 4 squared minus 4 times 2 times negative 1, all divided by 2 times 2. And again, I get all of those values simply from plugging our values from the quadratic equation into the quadratic formula. Okay, now, next step, simplifying. 4 plus or minus, the square root of negative 4 squared is 16, and 4 times 2 is 8, times negative 1 is negative 8. Again, remembering our rules, adding all over 4. Okay, so we get 4 plus or minus the square root of 24 all over 4. I'm going to come over here and I'm going to look at the square root of 24. I know that's not a perfect square, but the two perfect squares that it falls between is going to be 16 and 25, so very close to 25. All right, so I know 2 is a prime number. This simplifies to 12. Then I have 2, and I have 6. Then I have 2, and then I have 3. Okay, so this simplifies to 2 cubed times 3. Remembering that when I do this, 2 can only go in there one time. So I have 2 on the outside, a 2 remaining on the inside, 2 to the first. Same thing here. This is 3 to the first. 2 times 3 is 6, so I have 2 square root of 6. There are many other ways that you can simplify this instead of using prime factors. If you know that 4 goes in there and then you have 24 divided by 4 is 6, so the square root of 4 is 2, 2 square root of 6. Doesn't matter to me how you find it. So now we're left with 4 plus or minus 2 square root of 6 all over 4. Now you should notice that this term, and this term are all divisible by 2. It doesn't always work that way, but past few, it has worked that way. So our final answer is x equals 2 plus or minus 1 square root of 6 all over 2. Now you could simply write it as, let me get that over there. There we go. You could simply write it as 2 plus or minus square root of 6 over 2 instead of putting that 1. The other way you could write this is 1 plus or minus the square root of 6 all over 2. I just like to keep it this way as the simplified. All right, this is our final one as an example for today. So I'm going to subtract my 4x the other side. I'm also going to subtract 2 to the other side. So when I get this, my quadratic equation is 3x squared minus 4x minus 2 equals 0. Now I'm going to go through this one pretty quickly because this is our last example. So you can pause it if you want to try it on your own. Sorry if you're hearing my dogs barking, the lawnmower going. Nice day. So I did this one a little bit differently. Like I was explaining, instead of doing prime factorization, I knew that 4 was a perfect square. The square root of 4 is 2, and that goes into 40 evenly. The square root of 10 is not a perfect square, so I kept it the same. So here we have 2 square root of 10. Now going back to that rule that we did from the very beginning, most of the time 2 or 3 can go into these terms. So I divide this term, and this term by 2, not the number underneath the radical. Do not touch the number under the radical. So my final answer is going to give me x equals 2 plus or minus, again you can put the 1, you don't have to, square root of 10 all over 3. And this is my final answer for this one. There we go. Alright, good luck, have fun. I'm going to spend a few days doing this, so it's not just you have to learn this instantly.